Hello guys, my name is Mike Reinhardt, and today I'm going to show you how to build a item-based recommender system using collaborative filtering. So what's collaborative filtering? Collaborative filtering is where algorithms attempt to make predictions about users' interests by corroborating interests of other users. And you might want to know what's a collaborative filtering recommender system. It's where it makes predictions of what might interest a particular user based on taste of many other users. And there are two types of collaborative filtering recommenders. They're item to item and user to user. User to user, where it identifies other people with similar tastes to target a user and combine their ratings or likes to make recommendations for that user. Whereas item to item, it identifies global product association from items, but uses these associations to provide recommendations based on a user's own product ratings. So in this notebook, I will attempt to implement an item-based collaborative recommender and evaluate it using root mean square error to see how well it performs. So in order to get started, you only need these 6 modules: NumPy, Pandas, Math, Square Root, sklearn, metrics. You need the mean square error for our evaluation of the recommender. You need the pairwise distances to use a metric in order to measure the distance between the different vectors. And you're going to need the unsupervised learning algorithm nearest neighbors to make these recommendations. So you can download this dataset at grouplings.org, datasets movie lens. So you can click on this right here, and it's a link that's going to take you directly to their website. And there are, I believe it's 2 types of datasets. The 100,000, it's like the 100,000 ratings dataset, and you got the 100,000 movies dataset, and you have the million ratings dataset and a million movies dataset. So right here for this video, since I don't need a million rows of data, I only did the 100,000 ratings dataset and the 100,000 movies dataset. So here they are right here, the ratings. Just import it, put it in your directory, and you should be able to easily read it into a data frame using read CSV. I'm sorry. And so yeah, and here's the shape of the actual ratings data frame. Is over 100,000 rows and 4 columns, and for the movies data frame is 9,125 rows and 3 columns. So for the ratings, the data frame has 4 columns: the user ID, the movie ID, the rating, and the timestamp. And for the movies data frame, we have the movie ID, title, and genre. So as we can see, we will need to merge both of these data sets, but there is a similar key for both the data sets that we can merge on, which is movie ID. And so right here, I created a sub data frame, use merge and ratings in movies data frame on movie ID, and then I don't want the genre because I'm not doing a content-based recommender in this video. In the next video, I will show you how to do more of that. And so we drop timestamp and genres from the columns, and now after merging them, we still have over 100,000 rows and 4 columns, and this is the way it looks right here. Now we have the user ID, the movie ID, and all one data frame in their ratings and their titles. So now I want to build a item-based recommender. I want to know what movies the users have already rated. So what I did, I created a pivot table, which slash is actual, you can call it a matrix, where I use rating. These are the NANs. It's a very sparse matrix or a pivot table where there are numerical values in here. It's just so sparse that you can't actually see them right now. So the ratings are actually actual values were the NANs, but there are actually ratings in there. We just have to find them and, kind of sort, filter, and do all that stuff. And on the index axis, we have the user ID, the users that have, rated these particular movies on the column axis, and actual columns titles were all right there. So the reason why, like I said, I created the missing pivot table was to get that. It would be easier for me to get the actual values the users have already rated, and I can easily drop the missing values that they have not rated. So let's identify the movies each user have rated. This is what I did right here. Put in an actual dictionary. Created 2 dictionaries of the actual movie titles the individual users have rated, and I needed the row indexes to reference back later when building this, when trying to see which items are most similar to another item. So I looped through it, looped through this whole pivot table. I got the length of the columns, and I zipped the row index and its actual value, and the actual row, the actual numerical position of the actual column, and I need this, like I said, the actual column in order to reference back to see which column index was most associated with another movie. So it's easier for me to reference back using the actual index. So I zipped them all together, and like I said earlier, this is a very sparse matrix. So I'm trying to get the movies that the individuals have already rated by dropping the missing values, which was easier. So it would have been very easy for me. So what I did was I got the indexes the individuals have already rated, and I got the movie titles that the individuals have already seen, and I put them in the actual dictionary because I'm gonna need them later. And as you can see, these are the movies that they are rated for user 1. These are the movies that they have rated or seen. Let's go down to user 2. User 2 is Seen Addams Family, Aladdin, Apollo 13. Let's look at user 3. It's a lot of movies that they've seen. User 3. So forth. This goes all the way to 671, because notice we have 671 users in this data set, in this pivot table. So let's go down here, and here's the user item matrix, what you've seen above right here, but now it's filled with zeros. Those missing values, those NANs, are filled with actual zeros now. And so in order to, pretty much in order to evaluate which particular item was most similar to an item, we can't measure between different vectors NANs, missing values. So it was only right to fill that with zeros, because these are the values that the individual users have not rated. And what I did was, since there were a ton of movies and a ton of outliers that many, well, not really many, but a very small number of users have seen a movie, like you could say Kill Bill. It was possibly not too many people actually viewed that movie, so it's going to be considered an outlier. For an example, I'm not saying this actually is. I did all my homework to evaluate if it's actual outlier, but say Kill Bill, for example. A lot of people may have never seen Kill Bill, so it become an outlier. And the reason why I'm bringing this up, because I didn't want to use the regular ratings that the user have gave the movie because my results would have been very skewed and it would have created a lot of bias. So I converted those values into binary values. 1 if the individual have rated the movie, and 0 the individual have not rated the movie. This is where NP sign comes in effect. And I'm going to show you really quick right here. Insert, cell above. I'm going to just show you the matrix now, the updated matrix now. All the, where you previously seen the NaNs, they are now zeros. And there you go, right now. So here's a little look at it. And okay, so now we're going to move on down to where these are the movies not rated by a particular user. So like I did before, where I created a dictionary of the movies that they have rated. I'm creating another dictionary where the movies were not rated by them. So you see not rated indexes. I did pretty much the same thing to where I got the movies that they have not rated. Pretty much the same thing, same concept for the movies that they have rated above. And these are the movies that they have not rated. Great performance cast. As you can see, user 1 have not rated great performance cast. So, and I never seen none of these movies before. I seen Hellboy before. $9.99. I've never seen a movie before. You just clearly see that these are the movies that they have not rated before because it doesn't have a 1 associated with that value. So you can see right here, not rated, great performance cast, Hellboy, and you can go up here and see where user 1 only rated Ants, Beavis and Buttheads, and so forth. Yeah, starting to make sense, you guys. So now let's get to the good part. Let's show you how to actually build the unsupervised nearest neighbors recommender. In this video, I'm only going to do it 5 neighbors. So what this N stands for is the number of neighbors I want a movie. It's like the closest 5 neighbors to an item. So I created a actual a name, cosine nearest neighbors. I don't know why I put K nearest neighbors because it's not K nearest neighbors. It's only nearest neighbors. So I'm gonna take the K. This is only nearest neighbors, so I'm gonna take that out. So yeah, the nearest neighbors. So if you go Shift Tab, you get to see nearest neighbors 5, the standard. Radius, all that stays the same. Auto, the algorithm, I put brute because I want to exhaust all possibilities to find the closest nearest neighbors faster. And the actual metric, I want to use cosine similarity because that seems to be the most popular thing most recommenders respond to besides JCard similarity. Because the reason why I use cosine is because it measures the real value to real number vectors. So when you are given when this algorithm is measuring 2 vectors, it's measuring the distance between the 2 vectors. The closer they are together, the more similar that they are. The further away they are, pointing in the opposite direction of each other, the more uncorrelated they are. So that's the reason why I use cosine. And another popular one is JCard, where it's only pretty much binary vectors. And I could have used JCard. I did play with it and play with it a little, and it performed just as good as cosine. So I'm gonna use cosine in this video. Feel free. If you go down here, Shift Tab again, you can see down here you can go and change the algorithm. Change the metric to different distance measurements. If you go right here, you see JCard, you see, what else you see? A popular Pearson correlation. You also see up here, if I can click on it, give me a second. You see Euclidean, cosine, and Manhattan, and all that good stuff. So feel free to choose which one performed better, and you can also see how well each of those metrics perform better by making actual predictions, where we're going to get to down here at the end right there, as you can see right here, that good stuff. So we'll get to that later. All right, so let's get back to this. So I actually fit the whole value, fit the whole pivot table values. I could have did a train and test split to, predict on unseen data, but for this sake of this video, I'm only doing the whole data set just for practical uses. And so, okay. So now, since we fitted on the actual values, we want to see what are the nearest neighbors to those actual values that we were fitted on. We only want 5. We only want 5, as you can see right here. All right. So we're going to go down here to the actual recommender. I created another dictionary, and I looped through the index of the original pivot table, and from the item, it outputs the actual indexes. Oh, I'm having a hard time pronouncing any of my words. Indexes from the actual algorithm, and these are the indexes that are most similar to these particular movies. Let's see, particular movies right here. So as you can see, you have user on this side, you have the column and the titles on this side. So what I did, I transposed it right here. As you can see from the pivot table, I transposed it. So now on the index axis, you have the actual movie titles, which are up there. And on the column, if y'all want to see, I can show you. On the column, I have the actual users, the user names. So when you transpose it, I can usually show you right here. You can transpose it. So this is how it actually looks. All right. So you have on the index axis, you have the actual column. You have your actual movie titles and the user on there. So that's what that actual algorithm is computing. So I'm gonna go back to the original pivot table. So that's what it's actually computing, and it gives you the actual distances from a particular movie. It gives you the distances from that particular movie, and you can do 1 minus item distances, and you can get the actual similarity value, the similarity score, instead of the actual distance from that particular item or movie title, and it gives you that actual index of the actual movie. So here's the actual item-based recommender to see what items are most associated with another item. So I looped through it, like I said. I got the actual indexes for the in the indexes. I got the actual index, and I got the actual index name, and I turned it to a list, and turned the rest of it into a dictionary. So for the actual key in the dictionary, it's the actual the movies. It's the actual movies that are on. Let me show you again. These are the actual the keys are going to be the actual movies that you see right here. These are the keys, and the value is going to be what movies are associated with these keys right here. It's going to be more, just showing just 5 rows of this right here. So I'm going to go back to this again. I know this gets a little tedious, but I'm showing you guys today because I know you guys been wanting to see how I built this recommender. And so let's see what the items look like in the actual dictionary. So I'm going to go items dic, and let's see for user. Let's see for, matter of fact, let me just print the whole dictionary out and show you guys. Oh, so look, beautiful. So right now you see great performances. It's most associated with itself, which understood there's going to be a perfect similarity of 1 or 0, given if you 1 minus the distance or whatever. So Agent Coded Banks apparently is associated with Great Performance Cats. Like I said, I've never seen that movie before, so I don't know what Great Performances Cats is. Career Opportunities, 100 Rifles, Amelia, and same goes for this actual movie. Same thing, Hellboy itself, and many more movies down here. So easy, right? Easy, simple, straightforward. This is a item-based recommender, which it recommends items most associated with another item. In this case, our movies are most associated with another movie. easy, easy as pie, easy as 1, 2, 3. As you can see, it goes to all these. These are all the movies, all the way down to the last key. It didn't show all the last key because it got dot 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 down here. So okay, because it's using too much memory. So let's go down here. So yeah, now we got the movies that are most associated with each other. But hey, we need to figure out how to recommend these movies to individuals that have not seen these movies, and to make use of these movies that are most similar to each other. So we're gonna recommend these movies to particular users. I know you're wondering, how do I do that? So I'm going to show you right now, so it will make sense. So right now we want to recommend movies to users that they have not seen before. So I'm going to show you how to do that really quick. All right. So from the actual, remember, row indexes from above of the movies that the users have already rated. Here you go. I'm using this dictionary and I'm looping through it down here. All right, down here. So what this does is, for I in item indexes, for each movie in item indexes, I want to find all the indexes that are most similar to the movies that they already rated. I want the indexes, and I also want the distances. I did the same thing, and it outputs the movies that are most associated with movies each user have already rated. And then I combine them, the item and distance. The distance and actual movie index, and created another dictionary down here. So right here I did for distance and index and combine. If the index is not in V, because I don't want the indexes that are in V, it's going to recommend me movies that the users have already seen. So I don't want those. So I filter those. Created a dictionary, got the keys and got the values. I zipped them together and I sorted them. So the distances or the similarity scores will be in numerical order, from the most similar to the least similar, based off the movies that they have already rated and not have rated. So I filter the movies that they have already rated right here, because like I said, from right here it's going to include movies that they have already rated and the ones they have not rated. So I filter the ones that they have not rated. And so now I sorted them back. I sorted their distances, and I used the original pivot table. I got the column names, and I got the actual column names. So I needed the actual names of the movies that they have seen to put it in better perspective, and instead of just using the actual movie IDs or whatever, or just indexes. It won't make sense. You want to see actual movie. You want to see actual results. So yeah, these are actual recommendations. I put in an actual dictionary, and the K is the actual user. It's the actual user that I'm making these recommendations to, based off the movies that they have seen. They have not seen. I'm sorry. These are the recommendations for the users that have not seen any of these movies. They have not seen these are brand new movies that they have not seen, and I'm making recommendations to them based off the movies that they have previously seen before. So get recommendations. Here you go. I wanted the number. I want 30 recommendations for every user. I created a simple function to get the if the user, which is going to be an actual numerical integer, if the user is greater than the length of the index, which there are only 671 users, out of range there, I told it to print out of range, there are only blank, which are only 67 users. Try again. Else I want to print the actual movies that they've viewed. Print the the movies they have viewed in the past. So there's actual print of movies that are viewed in the past, and we're gonna print the actual movies that we're recommending them to, what the movies that they may be interested in, based on the movies they have viewed in or liked in the past. So created this for KV and Tyrex. If user is equal to the K which is the actual user, I want you to loop through the number Rex and V. The V is the actual values, and print the similarity score and the movie that we recommending to that a particular user. So for user, I said for user 601, these are the movies that they have viewed in the past. Dark Knight, what else? See That Guy, never heard of that before. Avatar, 28 Days Later. Seem like pretty good movies. You got Indiana Jones. You got Teenage Mutant Ninja Turtles 2. These are the movies that they have seen before. And I'm going to recommend movies that they have seen before. So we're going to recommend Teenage Mutant Ninja Turtles 3, since they already seen Teenage Mutant Ninja Turtles 2. Teenage Mutant Ninja Turtles, the first one looks like, the Avengers, but since they seen look like Batman up here, and you got Batman Begins. Oh, recommend Batman Begins, and many other movies that looks like it makes sense to me. Got Star Wars, is really similar to Star Trek, as you can see right here. A lot of good stuff. A lot of good stuff. Incredible Hulk, Marvel movie, in comparison to what they have up here. Like I said, Batman and Dark Knight right here. And to show y'all again, that this recommender is pretty robust, I'm gonna choose 500, user 500. Oh, look at right here. This particular person has viewed a lot of movies, as you can tell. So, Three Ninjas. What else? Let's see if they view like Star Wars. They viewed pretty much the whole Harry Potter series. Let's see if there are any other Harry Potter movies that we can recommend them to. Looks like they done viewed. They done viewed all the Harry Potter movies. Looks like, have they seen Star Wars? Let's see. Oh, these are the Star Wars. Star Wars. Let's look down here. As you can see down here, I recommended a Star Wars movie to them. Star Wars Episode 5, which they have not seen before. Makes sense to me, right? Let's go back up here. Star Wars Episode 4 and 6. Toy Story. They have, man, this is really good stuff. Terminator. Let me see if they view Terminator, the first Terminator. I love doing this stuff. It makes me excited, and I love building recommender systems. Let's try another user. They have viewed a lot of movies. Oh, sweet. Ace Ventura. Let's see Addams Family. Let's see what else. Let's see what kind of movies you're recommending now. These are the movies that they've seen. Independence Day, Star Wars, similar to Star Trek, Jumanji, Mission Impossible. There's like some good stuff. Let me see somebody else. Let me see. Try another one. Ants, Beavis and Butthead, Dracula. A lot of these movies are really. Star Trek. Go Star Trek finally. Star Trek. We're recommending for this particular user. Try Star Trek 3 and 5. It looks like, and Star Trek 2. So this recommend is really robust and is really strong. And it actually printed out the similarity scores. And so what I did 1 minus the distances between the movies, and to make it easier for me, and I sorted them from highest to lowest. Star Trek being the most similar to what they have viewed, and it looks really good. And you can toggle, like I said, if you go to 672, there are only 671 users. If you go 672, it's going to give you this error. Out of range, there are only 670 users. Try again, and going back to user 1. Makes sense, right? And these recommendations make sense to me. So let's make rating predictions for the movies users have not seen before. These are actual predictions for the movies that they have seen before. Keep in mind, these are not user predictions. These are item predictions based off of what a particular have viewed before. So this is going to recommend. It's not going to recommend. It's going to predict. It's going to actually predict the rating of what movies are associated with another movie. Make sense? So 1 minus distances, I get the actual similarity score. And here's my little prediction function right here. The ground truth are the original values. The original values in the pivot table that I put up there, and the item distances. I just need the indexes to reference back for the ground truth to evaluate these predictions. And like I said, this value. I'm sorry. All right, the pivot table. This is the actual matrix right here. The pivot table dot t transpose dot value is the actual its actual matrix. And this right here, item distances are the actual distances. Well, it's actually the indexes because I arc sort actual indexes from the item distances. And it was originally 3D, and I dropped it down to 2D by doing this open bracket, 0, close bracket to get it to 2 dimensions. These are the actual values that the ground truth for the actual item recommender that you saw up there. All right, this is what they used. So, and this is what I indexed. All right, so here I created a function, root mean square error, which is evaluating how many, just evaluate the closeness of how well this recommender performed. And it's really good, easy to looking at the predictions, and looking at the ground truth, and get the prediction. We're gonna index and get the non-zeros. So the zeros, we don't care about the zeros because that's perfect. We're looking for the non-zeros that are further away or closer to the actual true value in the ground truth, and return the square root, the mean square, the square is square root, the mean square error, prediction ground true of these two. And here's the actual error rate and the predictions from right here, the ground truth, got it right there. Here's the accuracy, 100 minus the error rate, and the root mean square error is the error. So this actually performed very well, damn near a score of 100% accuracy. So maybe to evaluate it a little bit more in depth. Like I said earlier, I would do a test and train split to just see how it performs on movies that it has not seen before. And I hope you like this video. Feel free to message me on LinkedIn, email me if you have any questions. For my next video, I'm going to do item recommender, to where for all of these recommendations that I'm rating, I'm recommended to a particular user. For user, keep in mind, we want to see what other users are most similar to one another. So for these recommendations that I've recommended to a user based off what they have viewed, I'm going to combine this with the user and to take a hybrid approach to make it more robust and make it more strong, because these are what companies want. This is what they're looking for, and this is what's similar to what Amazon, Spotify, Facebook, and what they use. They use a model-based approach, which is a unsupervised learning, and some use matrix factorization, dimensional reduction, which is pretty strong too. You can evaluate it pretty much a similar way, and I'm going to be showing you all these videos. Just stay tuned, and I hope you like this video. And I will post this notebook on my GitHub, and let me know what you guys think. This is my first video, and I know I didn't do the best, but I hope you like it.